Hey there everyone. Today we're going to learn about the software that we use every day that allows us to interact with the digital realm. I hope you'll join. Hey there everyone. Today we're going to learn about operating systems, how they make our lives 100 times easier, and how they've been changed to make our hair not be pulled out of our heads. To get started, let's discuss what an operating system is. And in order to do that, let's go ahead and actually look back on the history of what an operating system is. To me, an operating system is any system that allows, or technically allows for me to interact with the input and output of a computer. So when you're using a calculator or using your phone, what you're doing is interacting with an interface that takes your input and will spit an output back. The operating system is the middleman in between that allows for the tool to be used properly. So if we go back in history to these mainframe computers, these huge, giant towers that used to be what computers are, and look at them, they were really only buttons, dials, and levers. No digital aspects whatsoever. In these cases, these mainframe computers specifically had an interface of a physical interface. That's all they really had. Those dials, knobs, levers were the only way to manipulate the input that was going into the computer. So, with these mainframe computers, our operating systems served 6 primary tasks. And those included handling the input and the output, converting whatever the key presses, the levers, the dials, whatever that meant to that computer, into something the computer could understand, and then our computer system outputting that information, or at least having the operating system output it for us in a way, which in the back in the day was literally the printing of a paper. Alongside that, our operating systems had multitasking, which allowed for the processing of multiple calculations at once. With a CPU, or the central processing unit, as we had talked about before, we will actually have multiple little brains inside later on, not early on to the inception of computers, but with this we can multitask or think about multiple things at once. Then we have spooling, which mainly allowed for the copying of information from one space to another. Alongside that, we had batch processing, which is kind of like automating a process, kind of like how you make a batch of cookies instead of one cookie at a time. And finally, our early operating systems allowed for file management, moving a file from one place to another in this digital space that we had created with early computers. At this point, our operating systems work as a great way of keeping track of these digital assets that we've started creating with these early computers. They allow for us to create a digital space in order to manage the text and or information that we've created and or calculated with these computers. But in terms of being easy to use, in terms of being easy to understand, you practically have to have a math degree to manage one of these things at this point, which will transition us into the next big wave that really changed software. And that would be, the microcomputer. Somewhere in the late 70s, mid 70s, we started seeing microcomputers, or what you would be considered familiar with, which would be the at-home computer. It was in this era of computers that we saw our operating systems change, not only because they were on smaller, less powerful computers, but because, in this case, our computers had to be used by the average person. Because of that, we saw some introductions in this era that we still see to this day. So let's go ahead and take a look at a couple of those changes that really affected how we use technology today. To begin, we introduced what is known as the idea of kernels and shells. When it comes to computers, there are so many commands that are so odd and specific to math only that the average person would never use them, and if they wanted to use them, they'd need to program things themselves. Some computer programmers wanted for people to be able to use these functions of the computer without having to directly know what they meant. Thus, the kernel was born. The kernel, kind of like in popcorn, acts as the main seed holding the information and directly interacting with the code and or the genetics of the seed. With the kernel manages actually directly talking to the secret little math or the extremely complicated math that we would never want to use when actually using a computer, which is why we have the shell. The shell is the outer part of the computer that we as users actually end up seeing. You can think of it this way. When we move our mouse and or directly type something into the keyboard, that command is first sent to the shell, which, the application, which in our case is our operating system. This operating system has a shell which will translate the movement of our mouse and or the clicking and clacking of our keyboard and communicate that to the kernel, which will actually communicate to our processor or whatever chips we're using to run our computer, and have the input actually take action so that we get an output in our response. That output could be the mouse on our screen or a key appearing after you've pressed it. Now, in this era, we finally actually saw the kernel and shell abstract what we understood as a computer. However, we don't actually have mouse and controls at this point just yet. Currently, we would actually be working with something that looks like this, known as either a terminal or a command line. So even though earlier I had used the example of a mouse to interact with our kernel and shell, we would actually see something more in the context of a key being pressed on a keyboard. But it's also in this era that we saw the introduction of a GUI, or a Graphical User Interface. The GUI, one of the first mass-adopted GUIs, was actually Mac OS. So the iPhone that you use now, or the MacBooks that you use, are all actually rooted in the ideas and technologies that were made in this first version of Mac OS. With this, we introduced the ideas of dragging, dropping, as well as highlighting by clicking and dragging. This completely changed the world of computers because now your average person could come to learn how to use them. How exactly did the GUI, or Graphic User Interface, change how we interact with things? Well, instead of having to remember a bunch of commands, kind of like a wizard casting spells, you could just directly interact with the computer and not seemingly go crazy by having to memorize a bunch of commands. But moving forward, this is where we saw a large split in the operating systems, and we saw the birth of a lot of the operating systems that we use to this day. So, along with macOS, we saw the war of Unix and Linux begin. Now, what exactly is Unix and Linux? Well, most simply explained, with Unix, someone smart could make an operating system and have the rights to that operating system. They could choose to have it so that only they could sell it and only they could use it, the code that they wrote. Whereas with Linux, everything is open source, and you're welcome to modify and use the software however you please. Let's go ahead and look at some other examples. So, like I had stated earlier, with Unix, you have to purchase it from someone. You have to get it from the person who made the software. So, for example, Mac OS and Windows are the most common Unix systems out there. Now, these were all created in the 70s and introduce a lot of the things that you understand on operating systems today. Whereas with Linux, you'll most likely find them on cheaper laptops because they actually don't take as much to run, And a common example of a Linux system you'll see is Ubuntu. So at this point, we understand that operating systems mainly act as an interface for us to interact with computers directly. But what if the shape of our computers had changed throughout these 3 decades? And this is actually the exact issue we ran into in the mid-2000s when phones needed operating systems. So let's go ahead and transition into operating systems that we use daily that we only find on phones. And examples of this would be a dead version of Windows Mobile that no longer exists, Android, and iOS. These two are other different types of operating systems that introduced the concept of literally tapping and dragging on your phone, as well as accommodating for sensors such as cameras, IR sensors, and gyroscopes. So alongside these modern operating systems, we find with Android and iOS, we actually find macOS, as well as Windows and Ubuntu being our primary contenders nowadays. Now, with these softwares, we'll actually be digging into a deeper depth in these upcoming episodes. And in this next episode, we'll actually specifically focus on Windows. So, if you want to continue to understand computers and how we use them, join us next time and we'll take a deeper dive into Windows and its many tips and tricks. Hope you'll join.